Radical polymerization of ethylene, or let's make plastic. The initiation is going to start with the homolytic cleavage of a peroxide, giving us 2 radicals. And each one of these radicals then can add to a double bond and give us an ethene now that has a radical on it. And then that can react with another ethylene, and you just get a chain. You keep adding carbon units, and you can get a very long polymer. Very large molecules of 10,000 repeating units. You can also engineer in some branching if you want to. The termination occurs whenever any 2 free radicals come together. So the chain here has a free radical, and if you have too much of the initiating radical, they can kill each other, and then 2 chains can also kill each other. So we have to watch concentrations when we do these reactions. So if we do a polymerization of a substituted ethylene, we get, just for ethylene, we get plastic bottles, packaging material, insulation, and Tupperware. Propylethylene will give us polypropylene, which is carpet fibers, appliances, car tires. If we add a phenol group on there, we can get polystyrene, and we can make televisions, radios, and styrofoam. Vinyl chloride is, if you add a chloride group, you get vinyl chloride, and you can make plumbing, the white plumbing that you see. CDs, garden hoses, raincoats, and shower curtains. So we can also have the radical processes in the oil industry. Cracking converts large alkanes into smaller alkanes to make gasoline. So, halogenation as a synthetic technique. These are the things you need to remember. Chlorine is fast, but it's not selective, and you only want to use it if you have a very symmetrical molecule where all the hydrogens are going to be the same. Bromination is slow, but it's much more selective. So if you want to be selective, not get a whole bunch of halogens stuck in places you don't want halogens. You use these to introduce a functional group into an alkane. So I don't know whether you noticed, but when we were doing all our other synthesis, we started with something that had a functional group on it, and then we, took it off and made a double bond or whatever we wanted to do. This gives us the opportunity to take this and make that. Okay, so in this chapter we had 3 synthetically useful radical reactions. We had the bromination of an alkane. We had the anti-Markovnikov addition of hydrogen bromide to alkenes, which we actually used before, but we didn't understand the mechanism. And we have allylic bromination, where we have a bromine added at a carbon that is 1 away from a double bond. So you have made it through the entire chapter. Congratulations.